Alright, so we're going to start 11-7 right now. It's titled Special Segments of Circles. So the very first thing we're going to do is we're going to jot down something out of our books. Take out your journals, pause the video, copy that thing down. Okay, so what it's saying is if you have two things that intersect inside of a circle, then we can find the measure of each part of these lines or the entire line by knowing this, that AB times BC equals DB times BE. I like to think of it like this. Part 1 times part 2 equals part 1 times part 2. So, there's the formula. Hopefully you guys got this thing jotted down. So look at this example right there. This is a great example. Here we have two things that intersect inside of a circle. So we're going to have x times 10 equals 5 times 12, or 60 equals 10, or 10 equals 6, and so on. This one right here looks a little bit different, but it's the exact same. X plus 1 times x plus 8 equals x times x plus 10. And then you can pause the video and you can see how they go about solving this, that the x squareds cancel, subtract 9x, and x is going to equal 8. Okay, so this is how you find the different types of segments inside of a circle right there. All right, the next thing we need to copy down, and then we're going to do to our homework, is this one. So if two secants intersect in the exterior of a circle, so this is how we figure this thing out. Pause the video, write it down. Okay. So we can actually find the measure of these segments, like AD, AB, or AC, AE, and so on and so forth, by knowing that AC, which is that entire line, times the portion that's outside the circle. So AC times AB equals AE times AD. Okay? So look at this example right there. Here we have JG, which is x plus 8 times 8 equals 10 plus 6, because that's the entire line, times 6. So it's the entire line, or x plus 8, times the portion that's outside, equals the entire line, 10 plus 6, or 16, times by the portion that's outside, which is 6. And then you can solve it to figure out that x equals 4. Okay, hopefully you paused the video, got that one written down. Last one right here we're going to cover today is if a tangent and a secant intersect outside. So this one up here was if two secants intersect outside. This one down here is if a tangent and a secant. So pause it, copy it down. This one says that the tangent line squared equals JL times the entire line. So it's very similar up there. The entire line times the portion that's outside equals the tangent line squared. So the entire line times the portion that's outside equals the tangent line squared. Okay, so hopefully you guys got all those things written down. It should take you probably, I don't know, 20-something minutes to copy down all that information, those examples and things like that. So right now we're going to go ahead and go to our homework. And I'm going to do a couple for you off your homework, and then I'll send you off. So the first one is, let me see if I got this thing okay. Okay, right there. Alright. So what it does is it gives you a circle. It has a line that comes through like this. So this is an example of two tangents, and the way we know it's two tangent is because it intersects the circle at 2 points. So this is the information they give to us. They say that hx, which is h to x, hx equals 34, hw equals 68, and hz equals 25.5. And then they want us to find hy. So the formula is the entire line, so HW times the portion that's outside the circle equals the entire line times the portion that's outside the circle. So we can go ahead and plug in the bits and pieces here by going 68 times HZ, which is 25.5, equals HY, which we're after, times 34. Let me grab my calculator here. Let me make sure this is, oh yeah, we're good. Okay. I wish I could do that in my head. I can't. So 68 times 25.5 is 1734 equals HY times 34. And then we can just divide both sides by 34. So 1734 divided by 34 equals, so HY we know is going to be 51. So the entire line times the portion that's outside the line. The entire line times the portion that's outside the line. Okay, that's the first one. The next one we're going to look at has a circle, has a line that cuts it like this, another line that cuts it like that. This is V, N, M, J, K. The information they give to us, VK is 27, VN is 13.5, VJ is 18, and they want us to find MN. So, the formula, look back in your journal if you can't remember it, is, oh good, Tyson, good. You remembered the formula. Nice, man, nice. Okay, so the formula is Section 1, Part 1, so let's just say we can call it JV times VK, right, equals NV times NV. So JV right here is 18 times VK is 27 equals VN is 13.5, and they want us to find, oh, they want the entire line. So we do actually, so this is the formula. We don't know what MV is, but they want this entire line right here. Well, we already know what one part of it is. We know NV is 13.5, but we don't know this part right there. So what we're going to do is we first have to find MV, and then we can just add them together. So we're first going to find MV. 18 times 27, 486 equals 13.5 times MV. 486 divided by 13.5. So MV is 36. So we know that's 36. To be able to figure out what MN is, we can just go 36 plus 13.5 to get 49.5 would be what MN is. And that's the part that they wanted for their answer. Okay? Let's do one more of these, just because we want to here. Alright, so once again, here's a circle. Here's a line. There's another H, K, N, M, J. They tell us that HK is 10.5. HN is 21. HM is 14. And they want to find HJ. Let me make sure we can see this. We're good. Alright, so here's the formula. We'll just do it here. MH times HN equals KH times HJ. Do we know what MH is? Yeah, we do. It's 14. Do we know what HN is? Yeah, it's 21. HK is 10.5 times JH, which we don't know. Or HJ, sorry. HJ. So we're looking for this. So 14 times 21. Whoops. 14 times 21. That doesn't make any sense. 14 times 21. 294 equals 10.5 times HJ. Divide both sides by 10.5. HJ is 28. So we know the part that they wanted, which I believe was HJ, is 28 there. Okay. This one has, and the reason why I wanted to do another one is because of this problem. It's something different. What they're going to... Oh, no, it's gone. There it is. Okay, so it has a circle. Has a line that comes through like that. And then it's tangent to right there. So that's G. That's V. That's C. That's D. So the information they tell us is the VG equals 12, VD equals 20, and CD is what we're looking for. So we know this is 12, we know VD, so the entire line here is 20, and we're after CD, which is that part right there. Well, the formula is the tangent line squared equals the entire line times the portion that's outside the circle, so which is CV. So this could be CV right there, right? Because it's the entire line times the portion that's outside the circle. Tell me if I'm correct. I believe I am. Yes, the entire line times the portion that's outside the circle. So VD is 20. Let me make sure I got all this down right. Yep. And it wants us to find CD. So now CD is going to help us because we first had to find what VC is, and then we can subtract it from 20 to get CD. So we're going to have 144 equals 20 times CV, or 144 divided by 20, which means that CV is 7.2. So that little part there is 7.2. Now we can figure out that the entire line's 20 and they want CD. So we just have to subtract that from 20. And we get, is that 12.8 I think? So our answer here would be 12.8 is the solution that they want us to have on that problem. Okay, so that's it. Do your homework. Watch the video, take the notes that I wrote down, everything.